First one is false because the word disjoint is missing. And so if you look at the class summaries, I believe this statement is there and the word disjoint is necessary. So look at A equal 1, 2, 3 and B equals 2, 3, 4. And you'll see that if you take the union of these and compare the size, it's not the sum of the size. B, the question 2, this one is just counting how many cities there are, which there are a lot of commas, which can make it challenging, but there's nothing really. This is one that we thought was a trap previously. It's not a trap. The only thing that I would say here, it might be helpful in terms of visualizing, is when you think about sum principle, sometimes it can be helpful to think about drawing a box and then can I chop this up into boxes? So in this, we had the NC box, Tennessee box, and the South Carolina box. And then if you were trying to be careful, you could make sure you listed them all, perhaps with abbreviations, who knows. And then I can count how many there are because I've listed them carefully. And the point is, I know you can count to 10, but it can be difficult to make sure you've counted everything. And the second thing is when you do it this way, it connects it to larger problems. So looking here, I can sort of see that this is sum principle because I know that the sum principle is about disjoint sets, and I know that each of these cities is in one of these distinct states. So I know that these are different cases. When I say disjoint sets or different cases, that's really saying the same thing. Third question, J Cube, affectionately known to her friends as the quiz master. What you want to do here, what I would encourage you to do, is ask yourself 2 questions to try to diagnose whether something is sum or product principle, or perhaps a combination as you become more advanced. When can we use product principle? You have several steps or tasks. So think about when you need to answer a multiple choice question, how do you, physically you do something. You say Q1, what is the answer? Okay, well, it's A, I don't know. Q2, what is the answer? Well, it's B. You have to act it out. Maybe you don't need to get a multiple choice quiz and write it out, but you have to mentally act it. So you can think about this as Q1, there are 4 choices, A, B, C, or D. Q2, there are 4 choices. Q3, there are 4 choices. Q4, there are 4 choices. Q5, there are 4 choices. And each of these is a distinct step. So I can do 4 times 4 times 4 times 4 times 4 times 4 times 4. 4 times 4 times 4, which is 4 to the 10th. And I should probably have written 8 questions, 4 choices each, so that I knew to stop at 8. You could potentially recognize that answering a multiple choice question creates a function from the numbers 1 to 8 to the set A, B, C, D. So then if you're asked how many different ways are there to do this? Well, that's asking how many functions are there from the set of positive integers 1 through 8 to the set A, B, C, D. That's really the same thing this question is asking. Right. So I could use the skill of looking things up, go back to my class summary, search for functions, and then I see that this question was discussed previously in class and that we developed a conjecture about it. Now, what we didn't see was that the conjecture was true. We don't know for sure that this is a theorem. So maybe I don't trust our conjecture. So I could just search number of functions between 2 sets. And somewhere here, I'm sure there's an answer. But let me just go ahead and tell you the number of functions from x to y is given by the size of the size of y raised to the size of x. And maybe this didn't seem important when we did it in class, but now I recognize, hey, there's actually lots of times where anytime I'm making an assignment, I'm creating a function. So I have to be careful here. Is it 8 to the 4 or 4 to the 8? And it's 8 to the 4. It's the size of the codomain raised to the size of the domain. And we worked through that in class. We worked through how you have a bunch of slots. So if you believe product principle, and you say, okay, for slot 1, I'm going to have 4 options. It's actually the brute force, and in the proof, you've abstracted it. This is why brute force is better. Or maybe it would have been helpful to me to write out domain, codomain, and be more careful. Second, sign the second book. Third, fourth, sign the 4th book. So now I have 4 tasks, and I'm going to say, how many ways are there to do this? There's 7 ways to do the first one, 6 to do the second, 5 to do the third, and 4 to do the fourth. Do you see that? Because I'm not going to assign the same book twice. How long did it take me to write this out? It doesn't take that long. 5th question, Becky Hammond, she's running a summer league team. She has a roster of 13 players and needs to select a starting lineup of 5 players. Point guard, a shooting guard, small forward, and a center. So I have 5 tasks: point guard, shooting guard, small forward, power forward, center. I'm going to have 12 choices for my point guard, 11 choices for my shooting guard, 10 choices for my small forward, 9 choices for my power forward, and 8 choices for my center. I can't have people play both positions. I can't say, all right, you're point guard and center. That doesn't make sense. So here are my tasks. Here are my number of ways, and it's 12 times 11 times 10 times 9 times 8. And again, how long did it take me to write that out and give myself that? It feels like it takes a long time, but it really doesn't.